Hi, so our topic that is on the definite integral, where in the formula, that is the integral of a function of x dx evaluated from a to b, wherein a as our lower limit and b as our upper limit. The integral of the function of x that is evaluated from a to b. So this would become like this one. Okay, let's continue with our examples. So our first example, that is the integral of 2x minus 3 squared dx evaluated from 1 to 2. Okay, so solution here, that is our u here, okay, where u is equal to 2x minus 3 du is equal to 2dx. So therefore, we will have the integral of 2x minus 3 squared 2dx. See, so we multiply 2dx here. So 2dx. And then this one, we have our, we multiply 2. So we must multiply 1/2 here. So if we are going to look at here, this one is our u. This one is our du. So that is now a form of the integral of u to the n du. So evaluated from 1 to 2. So therefore, we will have 1/2. Okay. So you will have 2x minus 3. That is 2 plus 1. That is 3. Okay. So that is over 3. Okay. So therefore, we will have evaluate that one from 1 to 2. We have here 1 over 6. Okay. 1 over 6. Then you will have 2 times 2. So 2 times 2, upper limit. So you will have 4. 2 times 2, that is 4. Minus 3, that is cube. Minus, okay. So you will have minus 2 times 1, that is lower limit, that is 2. Minus 3, that is, then you will have to the cube. Okay. So be equal to 4 minus 3, that is 1. Okay. 1 raised to 3, that is 1. 2 minus 3, that is negative 1. So you will have 1 over 6. You will have 4 minus 3, that is 1. Okay, 1 raised to cube, so that is still 1. Okay, minus, you will have 2 minus 3, that is negative 1. Okay, negative 1. Cube, so that is still negative 1. Negative 1 times negative 1, that is positive. Times negative 1, that is still negative 1. So therefore, negative 1 times negative 1, so that will become positive. So 1 plus 1, that is 2. Divided by 6, so you will have 2 over 6 or 1/3. So the final answer here, that is, you will have 2 over 6 which is equivalent to 1/3. This is now the final answer. Okay, the next example, that is the integral of t, the square root of t squared plus 3 dt. Evaluated from -1 to the square root of 6, where our u is equal to t squared plus 3. Then our du, that is equal to 2t dt. We will have the integral of t squared plus 3 raised to 1/2. And then our du, that is 2t dt. Okay. Since we multiply 2, so multiply outside 1/2. So this one is our u, this one is our du. So we have a form of u to the n du. So therefore you will have 1/2, that is t squared plus 3, 1/2 plus 1, that is 3/2. So you will have 3/2 over 3/2 evaluated from -1 to the square root of 6. You can cancel 2 and 2. 1/3. Okay. Then you will have upper limit. So you start with square root of 6 square. So that would become 6 plus 3 raised to 3/2. And then you will have minus, okay, -1 square. So that would become positive. So you will have 1 plus 3 raised to 3/2. Then you will have, okay, so therefore you will have, so we will have 1/3 6 plus 3, 6 plus 3, that is 9. Square root of 9, that is 3. 3 times 3, that is 9. Times 3, that is 27. 27. Minus, okay, how did I get 27? That is 6 plus 3, that is 9. That is raised to 1/2 is square root of 9, that is 3. But 3 raised to cube, that is 3 times 3, 9. Times 3, that is 27. Okay, minus 1 plus 3, that is 4. Square root of 4, that is 2. Because you have 1/2 here. 2. 2 times 2 raised to 3, that is 8. Of 8 here. So 27 minus 8, that is equal to, so our final answer here, that is equal to 19/3. So that is our final answer. The next example, that is on the integral of y cubed dy dx, evaluated from 0 to 1 and 0 to 3x. So if you are going to look at this one, this is what we call double integration. So our next example, that is the integral of y cubed dy dx, evaluated from 0 to 1 and 0 to 3x. You start with dy. So when you are going to evaluate y cubed in terms of dy, your answer will be y to the fourth over 4. So you still have 0 to 1 here. Evaluated from 0 to 3x dx. So therefore, when you are going to evaluate y to the fourth, so you will have because that is y to the fourth, so your lower limit is 0, so therefore you will have 0 to 1, okay? Then you will have y, you replace that with 3x raised to 4. So 3 raised to 4, that is 3 times 3, 9. 9 times 9, 81. So you will have 81 x to the 4 over 4. So you still have dx. So this time, evaluate 81x to the fourth with respect to dx. So therefore, we will have 81x to the 5. So you will have 81x to the 5 over 20. So you have 4 here times 5. So evaluated from 0 to 1. So therefore, you will have evaluate from 0 to 1. So with respect to 0, that would become 0. So therefore, you will have 1 raised to 5, that is still 1. So our final answer, that would be equal to 81 over 20. So this is our final answer. The next example, that is the integral of dx, dy, and dz, evaluated from 0 to 3, 0 to 2, and 0 to y. This is what we call triple integration. So you start with dx, then after that one, dy, then after that one, dz. So your limits start with 0 to y, then after that one, 0 to 2, and then for dz, that is 0 to 3. You start with 0 to 3, 0 to 2. So the integral of dx, so that is equivalent to the integral of dx, that is equivalent to x evaluated from 0 to y. Okay. dy dz. Okay. So, x substitute with y, so that would become y. And this one, x substitute with 0, that becomes 0. So, therefore, you will have 0 to 3, 0 to 2, then you will have y dy dz. The integral of y dy evaluated from 0 to 2. So you will have 0 to 3. Okay. Y squared over 2. Then we will have evaluated from 0 to 2 dz. So we will have 0 to 3. Okay. So evaluate, substitute 2 to y squared. So that would become 4. 2 squared, that would become 4. Divided by 2, so you will have 2 dz. dz. Okay. Have 2z evaluated from 0 to 3. Okay. 2 times 3, that is 6. 2 times 0, that is 0. So, our final answer, that is 6. Okay. So, the next example, that is the integral of x squared dx dy. Evaluated from 0 to 1, then 2 to 2 plus y. So, we start with dx. So, we will have 0 to 1 x cubed over 3 evaluated from 2 plus y dy. We will have 1/3 0 to 1. We will have x cubed, upper limit, that is 2 plus y cubed minus x cubed, lower limit, that is 2 cubed dy. This is equivalent to 1/3 0 to 1. 2 plus cube minus 2 cube, that is equivalent to y cube plus 6y squared plus 12y dy. That would become 1/3 y to the 4th over 4 plus 6y cubed over 3. So that would become 2y cubed plus 12y squared over 2. So that would become 6y squared. So, close parenthesis. Evaluated from 0 to 1. This one, y to the 4th over 4, that is 1/4. Evaluated from 1, because that is 0, the lower limit. So, 1/4 plus 2 plus 6. 1/3. So, y to the 4th replace that with 1. So you will have 1/4 plus 2 plus 6, because this is 0. So minus 0. So therefore, this becomes, you will have 1/3. You will have 1. So you will have 1 plus 8. 4 times 2, that is 8. Plus 24. So therefore, equal to 24 plus 1, 25 plus 8, 33. 33 over 12. So that is now our final answer. The next example, that is the integral of w minus 1 times 2w plus 3 dw, evaluated from 0 to 1. So therefore, solution here, that is evaluated 0 to 1, w minus 1 times 2w plus 3, that is equivalent to 2w squared plus w minus 3 dw. Then the integral of that, so that would become 2w cubed over 3 plus w squared over 2 minus 3w. So these are all evaluated from 0 to 1. So therefore, we will have 2/3. So w cubed, that is 1. W cubed 0, that is 1 minus 0, plus 1/2. Okay. W squared, that is 1. W squared replaced with 1, so you will have 1 squared minus 0. Minus 3, 1 minus 0. So therefore, we will have 2/3 plus 1/2 minus 3. LCD is 6. By the 3, that is 2 times 2, that is 4. Divided by 2, that is 3 times 1, that is 3. 6 times 3 minus 18. So the answer here is 18 minus 7, that is negative 11 over 6. This is now our final answer.